Hello everyone, welcome to my new lesson video. In this lesson video, I will be discussing the naming of compounds. To be specific, all about binary compounds. Dito, ituturo ko kung paano ba natin pinapangalanan ang mga compounds. And I will also include what are the types of chemical bonding involved in the formation of these compounds. I am your teacher, Sir Mark Laroya. Before we directly proceed with naming of compounds, let us first recall the concept of chemical bonding. So by the way, I already have two separate videos of chemical bonding discussing the ionic bonding and the other one is the covalent bonding. So the description or the link of my two videos about chemical bonding are in the descriptions of this video. So for ionic bonding, this is a bonding between a metal and a non-metal wherein the metal will give up electron or electrons and it will become positively charged and we can call it as cation, while the non-metal element will receive the electron or electrons and will become negatively charged and we can call it as an ion. So ionic bonding is the bonding of two charged ions. Positive, the cation, and the negative, the anion. So these are the elements with fixed charges, the cations and anions. So first are the cations. So basically these are the alkali and alkali earth metals, elements with positive charges, okay? And this next elements are the nonmetals, or they are now the cation, rather the anions. They are elements with negative charges. By the way, the type of compounds that we will be able to form if we combine these two differently charged elements or ions, we call them ionic compounds. Or sometimes we can also call them as salts. So we will be able to form a binary compound if we combine a cation and an ion. So what are binary compounds? These are compounds made up of two different elements. In the case of ionic bonding, we will be able to form ionic compound, binary ionic compounds. So for example, we have sodium, a cation with a positive charge of 1, and chloride, an anion with a charge of -1. So if we're going to crisscross their charges, meaning the charge of sodium +1 will just become the subscript of chlorine, and 1 here of chloride will become the subscript of sodium. But since it's just 1, uh, we can afford not to write it anymore because it is already understood that if we don't see any subscript, it is automatic equal to 1. So this will become now NaCl, and we name it as sodium chloride, which is a type of salt, a table salt. So this is how we form binary compounds through ionic bonding. Another example would be the combination of magnesium, a cation with a charge of +2, and chloride, -1. So if we're going to crisscross their charges, 2 here will become the subscript of chlorine, while 1 will become the subscript of the magnesium. However, since it's just 1, we don't need to write it anymore. So this will become now MgCl2, or we name this as magnesium chloride. Another example would be for barium with a charge of +2 and oxide with charge of -2. Since their charges are numerically equal, they just differ in signs, we don't need to write their charges or subscripts anymore. It will just be cancelled out. So instead of Ba2O2, since they are numerically equal, they will be cancelled out. So it will become now BaO2. or simply we name this as barium oxide. And another example, aluminum with a charge of positive 3 and oxide of negative 2. So 3 here of aluminum will become the subscript of oxygen, and 2 will become the subscript of aluminum. So this will become Al2O3, or simply we name this as aluminum oxide. So this is how we formulate binary compounds, or should we say binary ionic compounds or salts, and this is how we name them, the binary compounds. Let us now talk about elements or metals with variable charges. These are actually transition metals in the periodic table. They are elements with two different charges. So for example, let's say you have the iron. Iron can have a charge of positive 2 or positive 3. So some other transition metals like lead will also have two different charges. Can be lead with a charge of positive 2 or lead with a charge of positive 4. So these are just some of the elements with variable charges. In naming them, when we combine them with anions, we use either stock system or old system. So for stock system, we simply indicate the Roman numerals indicating their charges, and for old system, usually the one with the lower oxidation or charge will end with OUS or US, and the one with higher oxidation or charge will end with IC or IC. So let us name some examples of these compounds. So elements with variable charges combining with anions. For example, let's use iron with a charge of positive 2 combining with chloride, negative 1. Since this iron is a metal with a positive charge, a cation, and chloride a nonmetal with negative charge, so this involves ionic bonding. If we're going to crisscross their charges, this will simply become FeCl2. We can name this in two ways. Either using the stock system, we can name this as iron 2 chloride. So we use the Roman numeral to indicate the charge involved in the formation of the compound, specifically for iron. And the second way of naming this is using the old system. So iron with lower charge, or for plus 2 iron, we use ferrous. So this is now ferrous chloride. So these are the two ways of naming compounds, binary compounds, ionic compounds, using elements with variable charges combining with an ion. Another example, for example, if we have iron now, this time with a charge of 3, and chloride again with negative 1, if we're going to crisscross their charges, the chemical formula of the compound will become FeCl3. So using the stock system, we can name this compound as iron 3 chloride, or using the old system, this is now ferric chloride. Another example here would be manganese with a charge of 2 and oxide with a charge of negative 2. Since their charges are numerically equal, that means they will not have subscripts anymore, because these two charges will be simplified. So this will simply become MnO, or manganese 2 oxide. The Roman numeral 2 indicates the charge of the manganese we use in the reaction between manganese and oxide. Or, using the old system, we can name this as manganese oxide, since we use manganese with lower charge or lower oxidation. Now, Another example would be lead with a charge of 4. This is a lead with higher oxidation or charge, combining with bromide, -1. So, the chemical formula now of the ionic compound that will be formed will be PbBr4. Using stock system, this will be named as lead 4 bromide, or using the old system, this is plumbic bromide. So this is how we name ionic compounds, binary compounds, using elements with variable charges combining with anions. So it's your turn now to do the naming of compounds. Determine the names of the following binary compounds and explain how they were formed. So, first you have BaBr2, the second one is CuCl, the next is Cr2O3, and then AlCl3. So you may pause for a while this video and then you try to name these compounds on your own, and then after you do this, after naming the compounds, you click again the play button, and then let's see if you get the correct answers or the correct names. Okay, so let us now name the following compounds. So the first one is the BaBr2. So this is actually barium bromide. So this barium is an element with fixed valence. It will only have one charge, and that is 2 positive. Combining with bromide, so by crisscrossing their charges, we will have a compound with a formula of BaBr2, or that is simply barium bromide. For number 2, CuCl, we can name this in two ways. This compound is actually formed by combining copper with lower oxidation or charge, which is +1, and chloride -1. So the formula will become CuCl. For using the stock system, we can name this compound as copper 1 chloride, or for using the old system, this is cuprous chloride. For number 3, Cr2O3, this compound is formed by combining the chromium with a charge of +3 and oxide -2. So if we crisscross their charges, the formula of the compound will become Cr2O3, or that is chromium 3 oxide, or using the old system, the name will be chromic oxide. And lastly, for AlCl3, this is aluminum chloride. Aluminum is an element with fixed valence that is only +3, combining with chloride. So the formula now of the compound which will be formed will be AlCl3, or that is aluminum chloride. Let us now talk about binary acids. So that means this is an acid composed of two different elements. And acids, by the way, are formed through covalent bonding. So again, for discussion about covalent bonding, if you haven't seen my lesson video yet, you can see the link of that video in the description of this lesson video. So covalent bonding. Binary acids are formed through covalent bonding, and these are acids composed of two atoms, a hydrogen and a non-metal element, specifically a halogen. The chemical bonding involved is covalent bonding because the two elements involved are both non-metals. So, hydrogen ion combining with a halogen will form binary acid. So, for example, hydrogen plus fluoride, we will form HF, or that is, we name this as hydrofluoric acid. So this is how we name binary acid, by using the prefix hydro, then followed by the name of the nonmetal but changing the last two letters with IC, and then you add the word acid. For hydrogen ion combining with chloride, it will now become HCl, or that is hydrochloric acid. Hydrogen ion plus iodide will create HI, or hydroiodic acid. And lastly, hydrogen and bromide will form hydrobromic acid with a chemical formula of HBr. Aside from binary acids, let us also name some other binary compounds that are formed covalently. So binary covalent compounds, these are compounds made up of two nonmetal elements, and they are formed covalently or through covalent bonding. So here are the procedures in naming these covalent uh, compounds, the binary covalent compounds. The first one is use the elemental name of the nonmetal furthest to the left of the periodic table. This will be the first element of the chemical formula of the binary compound. Second, the name of the second nonmetal element should end with IDE. So for example, bromine will become bromide. And lastly, use the prefixes like mono, di, tri, and others to indicate the number of those elements in the molecule. The first element does not use the prefix mono. So let us now name some other binary covalent compounds. For binary covalent compounds, we have the first one is the CO2, or carbon dioxide. So since we only have one carbon, we do not use mono because carbon is our first element. So for oxygen, we have two oxygen, so we use the prefix di and then we add the oxide. So this is now carbon dioxide. Next is CO. And again, since we only have one carbon, but carbon is our first element, we do not use the prefix mono. But for oxide, since we only have one oxygen, we can use the prefix mono, but instead of monooxide, it will be simplified into monoxide. So this is now carbon monoxide. CCl4. So this is carbon tetrachloride. Again, one carbon, so we do not use mono because it is our first element. And then we have 4 chlorine or chloride, so we can use the prefix tetra, indicating 4 chlorine or chloride. So this is carbon tetrachloride. And then lastly, we have dinitrogen trioxide, N2O3. Since we have two nitrogen, we can use the prefix di for our first element, so that becomes dinitrogen. And for our second element, the oxide, we have 3, so we have trioxide. So the name of our binary covalent compound N2O3 will be dinitrogen trioxide. Thank you so much for watching this lesson video. I hope you learned something new in chemistry, particularly in naming binary compounds. Please don't forget to subscribe to my YouTube channel, like and share this video to your friends and classmates. See you again next time, and God bless.